Good afternoon. I'm Paul Laidler from Powerol, based up in sunny Sunderland. We are developing and commercialising the next generation of energy generation and storage technologies. And we're doing that using our heavily patented groove manufacturing process. So I'll explain more about it in a moment. But the two products we're developing are next generation PV and next generation of energy storage. Both very, very pertinent products to today's markets. Excuse me. We've had the technology validated by several external bodies already. We've already got a string of commercial partners and opportunities. Our biggest challenge really is to develop the products through the supply chain and into manufacturing ready to scale up in the next 12 months. The first product is Powerol PV. And this basically, the proposition for both products is about low cost, low weight, and game-changing in terms of the economics which surround the products. This, the microgroove structure, if you can imagine a human hair, cut that into 50 pieces, and one of those pieces is the size of the actual structures that we're putting down onto plastic film. And what we're doing is we're using a roll-to-roll printing type of process, which makes massive difference to the capital investment requirements and to the costs for these products. There's a whole range of stuff there, but one metric there, we are targeting a seventh of the cost of traditional solar at the moment. And again, this is really very much down to the economics and the way we actually manufacture this product. We've already got a letter of interest from an Indian manufacturer. They want to use this product out in India once it's available. As I said, our challenge really is not finding customers. Our challenge is actually making the product and getting it through the supply chain quickly enough. How do we make it? We take plastic film on a roll basis. We then emboss these tiny little grooves into the surface. We've developed a vacuum deposition process which allows us to put small amounts of metals and materials onto the sides of the grooves. We then print a photosensitive ink into the groove, and then we slap a piece of plastic on the top to stop the rain and everything getting in to make it a solar cell. And we do this on a roll-to-roll basis, which gives us a complete product at the end of that sequence. So it's a very different processing method to what's traditionally done. It is unique. We haven't come across anybody yet who's doing this. To date, we've got efficiencies of 5 to 6% on our grooved cells. That may not sound a lot to most people, but in terms of the cost per watt, if we get above 6% with a commercial product, or 10%, we've already got a lot of customers in certain market applications who are really interested in the economics of this. The other product is a capacitor. As an example, you've got there on the left, there's a supercapacitor on the left-hand side, and that's our version of the supercapacitor. And on the right, we've got a power capacitor that we've made. So we're using this grooved architecture again with different materials, and we've developed different dielectric materials which are rather unusual to give us really high energy densities. So again, low-cost process, unique materials, and very, very high energy density. And one of the examples, we're working with the US military. They've actually done some tests across in the US, and we've got energy densities of 5 times that of lithium-ion batteries. So although these are small-scale samples, we've kind of proven the technical potential for these systems to make some very groundbreaking and low-cost products. Okay. There's some of the products. The ones at the top are some very early-stage stuff done on a manufacturing line in India. The power capacitor there, one of our capacitors is equal to at least 2 traditional capacitors. And I've already sort of mentioned about the supercapacitor down the bottom. You can see it's about the size of a pound coin, and it's equal to something between sort of 8 and 10 times its size in a commercial product market at the moment. So what we've got are a couple of unique, low-cost, definitely disruptable products. And we are looking now for people to help us with the scale-up, and we're looking for investors and partners to help us with the next stage of the journey to get this into the market, into a whole range of different applications. We're not going to manufacture. We'll derive the best process for making these products. We'll come up with the right manufacturing process, and we will license in this to other people to take in different applications and different markets geographically. There are several challenges ahead, but it's a case of finding the right partners to help us with those. We've made great progress so far. Yep. That blue line shows us where we're going, and in terms of, there's a range of products there. You'll see these slides, no doubt, on the web, hopefully after the presentations. And 15 patent families already in 46 countries. And finally, we've got 3 million in the bank now, but next year we're looking to raise another 5 to 10 for scale-up. So anybody who's interested in a scale-up partner, who's interested in helping us as a joint venture or a route to market, we'd be very interested in talking to you. And we are on stand 32. Thank you.